Fundamental of GIS. GIS people, today we are going to talk about number 32. Her name is Dawn Wright. Dawn Wright, marine geographer. Dawn Wright, aka Deep Sea Dawn by colleagues and friends, is a professor of geography and oceanography at Oregon State University in Corvallis, Oregon, USA, where she also directs Davy John Locker, a seafloor mapping and marine GIS research laboratory. Shortly after the deep-sea vehicle Argo, I was used to discover the HMS Titanic in 1986. Dawn used some of the first GIS datasets that is collected to develop her PhD at the University of California, Santa Barbara. It was then that she became acutely aware of the challenges of applying GIS to deep ocean environments. When we discuss the nature of the Earth's surface and the way in which it is georeferenced, we implicitly assure that it is above sea level. Dawn has written widely on the nature of geographic data with regard to the entirety of the Earth's surface, especially the 70% covered by water. Research issues endemic to oceanographic applications of GIS include the handling of spatial data structures that can vary their relative positions and values over time, geostatistical interpolation of data that are sparser in one dimension as compared to the others, volumetric analysis, and the input and management of very large spatial databases. Dawn's research has described the range of these issues and applications, as well as recent advances in marine map making, charting, and scientific visualization. Dawn remains a strong advocate of the potential of these issues to not only advance the body of knowledge in GIS design and architecture, but also to inform many of the long-standing research challenges of geographic information science. She says, the ocean forces us to think about the nature of geographic data in different ways and to consider radically different ways of representing space and time. We have to go super-dimensional to get our minds and our maps around the natural processes at work. We cannot fully rely on the absolute coordinate systems that are so familiar to us in a GIS, or ignore the dissimilarity between the horizontal and the vertical dimension when measuring geographic features and objects. How deep is the ocean at any precise moment in time? How do we represent all of the relevant attributes of the habitat of marine mammals? How can we enforce marine protected area boundaries at depth? Much has been written about the importance of error and uncertainty in geographic analysis. The challenge of gathering data in dynamic marine environments using platforms that are constantly in motion in all directions. Roll, pitch, yaw, heave, or of tracking fish, mammals, and birds at sea creates critical challenges in managing uncertainty in marine position. These issues of uncertainty also have implications for the establishment of dependence in space. Dawn and her students continue to develop methods, techniques, and tools for handling data in GIS, but with a unique oceanographic take on data modeling, geocomputation, and the incorporation of spatial temporal data standards and protocols. Take a dive into DKV John's locker to learn more.